Presentation of dialogue on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family's legacy of building the great state of Idaho.
What do the accidents at the nuclear plant in Japan mean for the future of the nuclear industry? The Idaho National Laboratory leads the nation in this type of research. We'll talk with the INL's director and find out what happened and what the aftermath may be. Stay tuned. Dialogue is next. Hello, I'm Joan Cartan-Hansen. Thank you for joining us here on Idaho Public Television, on the World Wide Web, and on public radio stations. When the earthquake happened on March 11th, the 6 nuclear reactors at the Fukushima Dai-ichi plant did what they were supposed to do. They shut down their emergency cooling systems, and those emergency cooling systems started to operate properly. The crisis came a half an hour later when a 33-foot tall tsunami wave inundated the plant, and the power systems for the water pumps used to cool the reactors and the adjacent storage ponds failed. Without electricity for the pumps to keep the reactor core covered with water, the exposed fuel elements reacted with steam and produced hydrogen. The gas built up in the reactor buildings and exploded the upper shells of the buildings over reactors 1, 3, and 4, and also damaged the building housing for reactor 2. And without electricity, the pumps used to circulate water in the cooling ponds where spent fuel rods were stored failed. Normally, water covers the spent fuel rods containing the radiation and slowly cooling them down. But with no water circulating and the pool exposed to the air, the water started boiling away, leaving the stored spent rods exposed, heating up, and releasing radiation. Plant officials have dumped in seawater and pumped water from fire trucks, hoping to cool the reactors and the pools containing spent rods. Electric company workers have hooked power back up to the main plant, but turning on power must proceed slowly because damaged equipment could trigger new fires or explosions. Outside the plant, residents in a 12-mile radius have been evacuated, and those within 20 miles have been told to stay indoors. U.S. officials called for Americans within a 50-mile radius to leave. Officials have also found higher than normal levels of radiation in drinking water, some food, and seawater around the plant. Though only minuscule amounts of radiation have actually been detected outside of Japan, the political fallout is worldwide. The Director General of the International Atomic Energy Agency, the IAEA, has called for a reassessment of the international nuclear framework, how the world will deal with nuclear accidents in the future. Countries like China and Germany have put a hold on new nuclear plants. And U.S. Energy Secretary Stephen Chu reassured members of Congress, saying regulators are reviewing the safety of U.S. reactors.
What we want to do is look at what happened in Japan and look to whether we would be vulnerable to a cascade of multiple events and how they might compromise safety.
So what does this reassessment mean for the nuclear power industry? And what does this mean for the Idaho National Laboratory? Joining me now is the director of the INL, Joan Grossenbacher. Sir, thank you for being here. I appreciate you joining us.
Good to be here.
And just to let viewers know, because of scheduling, this program has been taped, so we aren't taking live calls, but I do have questions from our Facebook page. So let's start. Does this accident mark the end of the nuclear power industry?
No, I don't think so. I think there's going to be and should be a serious evaluation of the performance of the technology, nuclear energy technology, under extreme circumstances. I mean, Mother Nature dealt it, two almost simultaneous blows and severe ones. 3 Mile Island, by contrast, wasn't caused by a natural disaster. It was a mechanical failure and operator error. So in this case, technology is being challenged. We have to see how the technology performs. I mean, clearly the plants are broken. There's 3 reactors with fuel that has been damaged, and that's about as serious as it gets in terms of that particular technology and reactor technology. You don't damage the fuel. You keep the fission products inside and away from the people. And in order to control pressure, they've had to vent some of that radioactivity outside the containments, which is also bad. I mean, this is much more serious, in my opinion, than 3 Mile Island. 3 reactors instead of 1. And they've actually had to release radioactivity that has created contamination, measurable contamination, outside the site. Now, the next question is, what does that mean in terms of public health and safety? What's the real impact? How many people are actually hurt by the radiation exposure? So it's very serious, but I think in the final analysis, the technology will be judged by the issue of how public health and safety was affected. And to date, and you can read, we all read the same reports coming from Japan. There's been on the order of about 75 people, as I count them, who have had radioactive contamination on their skin. That's been removed, and if you can estimate the dose rates associated with that, it's very low and not a significant health hazard. One of the workers, by Japanese reports, received a dose of 10 rem, which the Department of Homeland Security's kind of rules for this say if you need to save a life, you'll expose somebody to 25 rem. So we would expect this worker to have no measurable biological effects as a result of his radiation exposure. It takes about 500 rem, an exposure of about 500 rem. If you expose 10 people and they don't get medical care, about half of them would likely die from such an exposure. So 10 rem is serious. I mean, there's no doubt about it, but no one's been killed, and I don't think we'll know the real impact on public health and safety. The food contamination, the water contamination, the iodine, for example, has a short half-life and doesn't last very long. And it looks like with the evacuations and the sheltering of the public and the control over the food and water and the sensitivity to that the Japanese are doing the right things to protect public health and safety.
Assuming they can get the radiation releases from the plant under control within the next week or so, how long will the area's food, for example, the spinach, for example, they're no longer accepting it. Hong Kong is no longer accepting food from that part. How long will radiation stay in the ecosystem?
Well, it's very hard to know because we don't know the real extent of the contamination yet. The iodine is expected in some of the food samples, for example, and there are reports of ground contamination of cesium, which has a longer half-life and in many ways is much more difficult. So once we have more on-the-ground sample results, then I think we'll be able to estimate that. But I would expect, the Japanese to be pretty aggressive about containing that, cleaning it up, and then moving forward. There's certainly nothing yet that would indicate there's levels of contamination where you're going to say, well, we're not going to occupy, that area for years until it decays.
For example, this is not Chernobyl. I guess on the international scale, Chernobyl was a 7,
right,
and 3 Mile Island is a 5, and they're putting this one somewhere in the middle at a 6. And that
and that's a
1 to 7 scale.
And again, my opinion is it's more serious than 3 Mile Island because 3 reactor cores are damaged, and the release of radioactivity at 3 Mile Island was gaseous. It dissipated. Nobody got there was no measurable health impact. Here we've actually had civilians contaminated. It's far different, and Chernobyl was very, very different because you actually had a steam explosion and a graphite fire, and you blew the radioactive material and fission products both up in the air and in the surrounding area. I mean, it was a real mess.
Both China and Germany have been pushing more and more nuclear power. Have both now said they're going to pull back. Chancellor Merkel said that she really wants to move on to something else. If the world is going to move, do you think the world is going to move away from nuclear power, or is this just the panic of the moment?
Well, I don't get to decide. You know that. I think, and just to be clear, in the case of Germany, they actually shut down, I think it's 8 of their reactors,
right,
and they're their older reactors, and they're going through, I think it's about a 30-day moratorium to assess the safety of those plants. The Chinese have said that they're going to slow down. They're going to stop. It's not clear how long that's going to be or whether or not they're going to move forward. I think we're seeing 2 tests here. One is a test of the technology, and I talked about that. The second is in how do people judge the technology and the cost, risks, environmental impacts of this energy choice compared to the others. And a good example is if you look at 3 Mile Island and how did the rest of the world react to it and how did the United States react. The hiatus in large-scale deployment of nuclear energy in the U.S. was not solely because of 3 Mile Island. There were other factors, but certainly that was a significant one. But France, certainly Japan, Korea, And many other nations looked at 3 Mile Island. They learned from it, and they said, we still think, the risk-gain calculus is there's more gain from this technology, and the risk is acceptable. So they went forward. So the test is, how does the rest of the world understand and then interpret what happened in Japan, and then how do we do that in the United States?
Why is it so difficult for people to balance the risk factor for a source of power like nuclear energy versus more carbon? We know air pollution kills people consistently. Why? How? And yet we don't seem to have as much fear about that as we do, as some people do, about putting a nuclear plant in.
Yeah, I think there are a couple issues. One is just it's technically complicated. We really do need to understand radiation. We all get radiation whether we want to or not by living on planet Earth. Well, how much is that? And then how much do we choose to get through dental x-rays, mammograms, CT scans? The benefits are enormous from those applications of radiation. So first of all, there has to be, I think, an understanding of that. I think the second thing that contributes to it, it is very technical, but because of the risks associated with nuclear energy, we look at and we talk about everything that's possible. And then we reduce the risks to probabilities that we accept. And I don't want to trivialize it, but I like the airplane analogy. When we get on an airplane, we know that it's possible that bad things can happen. Pilot error, the machine breaks, and there could be a bad outcome. But we don't calculate the probability of that every time we get, and we don't talk about it. We know it's a risk, but the probability is so low, we accept the possibility and we fly anyway. And I think because of the hazards associated with nuclear technology and the role of the regulator and what we demand of ourselves in fielding it, we talk about what's possible all the time. And I think that also makes it heightens the sensitivity. Now, the risks and the hazards of these materials are very real. So they need to be respected. So that's appropriate, but I do think that's different. I don't think we do that with other technologies, and I think it's the right thing to do with nuclear technology.
One of our first Facebook questions came from Linda, who wanted to know, considering they've reassessed earthquake patterns, are the nuclear plants we have, are they safe, the ones in the United States?
Well, I think the U.S. Nuclear Regulatory Commission has already spoken to this, and certainly, my view is the answer to that is yes. Now, in the case of this earthquake, and you have to look at the kind of fault that is off the coast of Japan there and the risks associated with that. But clearly, from the standpoint of the design of the plant, Mother Nature surprised us. The earthquake, at least in my reading of the Japanese reports, they would say that the plant was designed for magnitude 8. This was magnitude 9, and the tsunami was much larger than the design basis of the plant. So why did Mother Nature surprise us? Why didn't we have enough margin so that we weren't surprised? I think those are questions that have to be asked and answered, and we're always learning things about seismology and earthquakes. So can we learn some things? And sure. But I think there's nothing to indicate that there's some new discovery that somehow this seismology and the work that went into the designs of the plants we have today is somehow wrong. It's not.
Can we technologically design to withstand nature's worst?
I think the answer to that is yes, and the but is safety is relative and risk is never zero. And again, I think the airplane analog is a good one for it because it's a technology that we're all familiar with and we all understand the risks associated with it. But large-scale industrial activities of any kind have costs, risks, and environmental impacts, and the safety is relative and the risk isn't zero. And again, an example I like to use is a number of years ago we had an explosion in a sugar refinery in the United States that killed a number of people. Tragic explosion. We expect that the people responsible for that technology will fix that so that we don't hurt or worse yet, kill people in using that technology, but we're still using sugar. We're not. And again, I'm not trying to trivialize it.
There are people who were significantly scared by that. And the fact that infants aren't supposed to drink the tap water, That's a scary message.
Yeah. Oh, it is. It is. And I think the Japanese are doing everything appropriate to ensure that there's no accumulated dose of radiation that could harm a child, and that's absolutely the right thing to do. But if you want to live in a life without radiation, then
you can't sleep next to somebody.
Well, you can't live on this planet.
Yeah.
But man-made radiation is the issue here, and we ought to be very demanding about not. The general public should not be exposed to radiation that they don't choose to be exposed to, and it's usually medical procedures. So it's very serious. Now, when it's all said and done, and we understand the outcome, how many people were hurt by it? We need to understand that, I think, to rationally judge the impact on public health and safety.
It is a bit hard to separate the earthquake from the tsunami and the accident at the plant, because you're looking at potentially 20,000 people killed by the earthquake and the tsunami. And then you also have this plant going on as well. That amount of devastation is hard for sometimes to separate. All the damage obviously wasn't created because of the plant. Well, let me ask what the scientists of the INL are doing. What's the role of the INL in solving this problem?
Well, first and foremost, the immediate response is in the hands of the operational professionals and the regulators who operate and maintain these kind of plants all the time. They're familiar with what to do under extreme conditions, so they're off trying to do the right thing to protect public health and safety, and they're doing those things. We're doing a number of things. First of all, we've contacted our sister laboratories in Japan that are responsible for this kind of research and told them that if you need help, if the industry or your regulator turns to you with a problem that they didn't anticipate or some analytical work they need done, and you need somebody to think with you, or can we use our high performance computing to help you, that we'll do that. Secondly, the lab is connected to both the Nuclear Regulatory Commission and, of course, through the Department of Energy and the industry to provide the same kind of service. And we've tried to organize the other labs in the U.S. with nuclear energy expertise so we can, on a given moment, tap the expert in this area. And one of the things we're trying to do is stay ahead of the problem. That is, try to think about things that perhaps in the heat of battle, the operators and the regulator haven't thought about. So early on, it was pretty obvious to us that we got to think through the salt water issue. As water boils, the salt precipitates. That can insulate the fuel and make it harder to cool. What's that going to look like? What should you do about it? And we're trying to think ahead. There's other things we can do that are confirmatory. So, for example, some of the samples that the Japanese reported, we can go back and analyze the data and say, that radiation came from a reactor. It didn't come from a spent fuel pool, and we can tell that. And so that kind of thing that they may not have time to do right now, I think is very helpful to them. We're trying to play a constructive role.
Is that what the IEA is talking about when they want to reassess the nuclear industry framework structure to try and set up systems so that scientists can communicate more easily?
Oh, I don't think so. I'm not. It's not exactly clear to me what the IAEA is going to look at here. They do provide a useful framework and support structure internationally, and it's very important, particularly with the large number of nations that don't have nuclear energy capabilities today and want to get into them.
Let's talk a little bit about those spent fuel rods, because was that something scientists didn't expect?
No, I think everyone knew, where that each one of these reactors had a spent fuel pool, and there was also a common spent fuel pool. Right. They also know that, for example, the spent fuel pool for reactor number 4 was a particular concern. That reactor was completely defueled, so all the fuel was taken out of the reactor, put in the spent fuel pool. They're not finished with it. They're doing maintenance on the reactor, and the plan was to put it back in. So it can be particularly fresh and hot. Right. So the issue was, are the spent fuel pools damaged by the quake or the hydrogen explosions? And there it's difficult because you don't have access. So we don't know. We just know what the Japanese reported, and there's been some difference of opinion as to whether or not the water levels actually decreased to where they were dry. If you keep them full of water, even if there's boiling, if you keep it full of water, you can prevent the fuel from melting and throwing more radioactive material into the atmosphere. So right now, because they're covered by debris from the explosions, the Japanese have been taking the forceful approach and using water cannons and everything else to dump seawater to make sure that those pools have water in them. But I think if there's anything I didn't anticipate, I'll tell you, Joan, I was surprised by the hydrogen explosions, repetitive. My understanding of the technology is that U.S. reactors of the same kind, they have a way to vent that outside the secondary containment so you can't get that kind of accumulation of hydrogen. And why it occurred, my understanding is as well, and I may be wrong, but my understanding is the Japanese plants have that as well. But there's something there I don't understand, how they accumulated the hydrogen. That was the only surprise I think I've had.
With the U.S. reactors of this same design, is there now some concern that we need to perhaps take those offline or look at bringing in new technology? Are they at the end of their lifespan in that type of technology? Is this going to hurry that along?
Yes, ma'am. No and no. I don't think they're at the end of their lifespan. I think they were safe on the day before this earthquake. And this isn't an act of faith. This is an act of fact. They were safe. Yeah. We believe they're safe now. Now, can we learn anything from the Japanese experience that says we should change things at those plants? The Nuclear Regulatory Commission, the industry, will certainly do that, and we expect them to do that. We demand that they do that. But there's no reason to believe that they can't be operated safely and public health and safety not hazarded.
Officials in New York and California have both argued for closing plants in those communities. Now, that may be part of politics as well as safety concerns. How do you think the industry as a whole is reacting to this crisis?
Well, I don't speak for the industry. I think they're reacting very positively and professionally. This is a very serious incident. Let's help our Japanese colleagues. Let's figure out if we can learn anything from this. But again, I go back to where I began. This technology has dealt a severe blow by Mother Nature. How does it survive it in terms of the impact on public health and safety? And I think the posture that I see from the commercial nuclear industry in the U.S. is very responsible. Is there something we should be learning here? After September 11th in the U.S., for example, as based on direction from the NRC, the commercial world industry in the U.S. implemented some extra measures to ensure, if something extraordinary happens that you never even thought of.
Right.
What are your alternative approaches? How can you provide electric power, cooling water, whatever it is? And to the point where the regulator has demanded that kind of preparedness on the part of the industry, and they inspect it. And I noticed, shortly after things started in Japan, the Institute for Nuclear Power Operations, which is an industry nonprofit organization that oversees and attempts to raise a very high level of performance in terms of excellence in plant operations among those reactors, put out a directive to all the commercial plants and go back and verify these things. This is, we need to make sure that we have all these backup systems, that the hoses and connections, because we never use them, that they really are where we said they are, and that we're living up to our standards. And so they're doing that self-inspection already. So I think they're pretty responsible.
The Obama administration has stood by its support of nuclear power, and they still actually have billions of dollars sitting out there for loans for new commercial plants, but only one commercial plant is currently under construction from that loans. With this little twist, do you think there are investors out there who are willing to put forth commercial plants?
Well, the investment decision in nuclear energy, and this gets a lot of debate about loan guarantees and whether or not it's a subsidy. Here's the problem. Here's the challenge. Nuclear energy is a long-term investment. When you build a new nuclear power plant, it's a 100-year piece of energy infrastructure. If you do it as a pure business deal, you may not even make $1 until 20 years into it. And that's a guess. Maybe it's 17. Maybe it's 23. Well, what kind of a business is that? I mean, that's very difficult. That's why every place else in the world, it's almost entirely a government enterprise.
And should that be what we do in America? Should we just admit that this is what we need to do? If we're going to have that kind of power, it needs to be a government operation.
I mean, that's an interesting, that's an interesting policy decision. I mean, what we try to do is with things like loan guarantees, is create the right mechanisms so that the commercial world will respond in a way that makes long-term investments that otherwise you'd never make, that are in the best interest of the country. And I think to answer your question, we have to ask ourselves whether or not those mechanisms are sufficient to get that kind of behavior out of the private sector.
Do you think this will just be a kickstart to U.S. Energy policy discussion? We now, if we're going to question nuclear power, we got to really question the whole issue, and I've only got a couple of minutes left. So,
well, I think that would be a positive outcome, and I would like to see that, Joan, for a number of reasons. You know, it's all about choices and costs, risks, and environmental impacts, and practical choices. You know, we got to have energy that gets us through the next 5 years, 10 years, 25 years. Not theories and not pie in the sky technologies that haven't proven. So how are we going to get from here to there, and how are we going to get outside the United States and provide energy to a energy hungry, I would even say desperate world?
And we have about 30 seconds to tell me left. What last message do you want to leave with the public about the accident at the Fukushima Dai-ichi plants?
Well, I think it's very important to understand the extreme circumstances the Japanese are in, be supportive of them in any way we can, and I also think that do an objective evaluation of the outcomes based on the real impacts on public health and safety, and take the time to understand what radiation exposure means, because that's going to be the measure. Did we hurt anybody?
And there's a difference between how they measure it, and we measure in rem, and they measure in sieverts.
Sieverts,
so
yes.
It's that Fahrenheit Celsius stuff that's going to confuse people. Sir, thank you. I appreciate you joining us today.
That's my pleasure, Joan. Thank you.
Let me tell you, we have lots of links and more information about the plant, and where you can get more information, including folks at the INL radiation detection that's being on there. All that's available, those links are available on our Dialogue website. You can go to idahoptv.org. Also on March 30th, NOVA will be presenting a special on the Japan killer earthquake. You can check it out at 8 p.m. on our main channel, or watch it later on the idahoptv.org player. You can check that all out at idahoptv.org. Again, the NOVA special is Wednesday, March 30th, 8 p.m., 7 p.m. I also encourage you to donate to the American Red Cross's Japanese earthquake and Pacific tsunami recovery effort. You'll find a link to that as well, the American Red Cross site, on the Dialogue page website. And I invite you to become a friend of us on Facebook or follow us on Twitter. Thank you much for joining us, and we'll see you here next time for Dialogue.
Presentation of Dialogue on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family's legacy of building the great state of Idaho. Check out our website, become a friend on Facebook, or follow us on Twitter.